my name is Yaron. I'm CEO and co-founder of Robust Intelligence. What Robust Intelligence does is it helps organizations secure their AI transformation. So just in maybe 30 seconds or less, the biggest problems that enterprises have right now with deploying AI is not so much the technology as much as it is that last mile of deployment, which is all about security and safety, right? So we've seen, organizations that can basically push out generative AI applications within a weekend, right? But for most enterprises, especially the ones in regulated industries, that journey is, could take infinitely long. And the reason is because, the safety and the security of the applications is key. So what we do at Robust Intelligence is we automate that last mile of deploying AI. And we do that through validation and testing that we're going to talk about today, and also protecting the application in real time. Okay. So that's just a little bit about me and about Robust Intelligence. And I want to let Yassir and Ed introduce themselves. So
my name is Yassir Nawaz. I am the head of security for our chief technology office. I'm responsible for securing all the emerging tech at JPMorgan Chase.
I'm at Bowen. I lead our AI Center of Excellence at Deloitte. So I have a team of about 100 AI researchers, and we work on problems where you have to innovate on top of existing technologies and invent to solve problems in cybersecurity, fraud, waste, and abuse, different types of language problems, all kinds of problems that professional services typically support. I came to Deloitte about 4 years ago. Before that, I spent 20 years in life sciences. So I was working on AI problems in protein engineering, molecular design, genomics, translational research, and drug development.
Great. I want to get us started by, kind of as we're talking about AI and we're talking about AI safety. I want to start by basically asking, how do you? Is more about like how to start even thinking about AI security, AI safety, how to think about policies, how to think about managing risk. So I guess my question to both Yassir and Ed is, how do you think about how should one think about AI security? How should one think about creating policies? How should we think about that from an organizational perspective?
I'm part of our cybersecurity, function within JPMorgan Chase. So I will talk from that perspective. So the first thing I would say is that, if you're a medium or large size enterprise, you probably already have a technical risk management strategy. You have a risk management framework. You probably also have a controls framework. And what I would say is that all of that apply. That gives you a very good foundation. Nothing, that's in there is extra. So all of that gives you a foundation. So the first thing I would say is that, look at your, use of AI and, the model development, and make sure that, the scope of your existing risk management framework extends to those, to the AI and to model development if it does not. Right. So once you're able to do that, that gives you a good foundation, right? And you also find, several gaps, as you do that. Once you have basically done that, the next step would be to then focus on AI specific risks. And there are a bunch of, frameworks out there. MITRE has Atlas, which is a very good, threat framework. NIST has AI risk management framework. Leverage that to basically extend your existing frameworks with AI-specific risks. And that would basically take care of the policy side of the thing. So once you've taken care of the policy side and you've uplifted your policies and your risk management framework, the next step is to take a look at your model development practices. Document your model development lifecycle, right? Figure out what it is, how models are being developed, where they're coming from, what is the supply chain. Once you have documented that, then you can basically overlay your risk management framework, and that would give you sort of a roadmap to then address the gaps that you have found in that risk management framework, right? So that is the approach that I think, is a very rational approach. It builds on what you already have. It leverages what already exists. and that it gives you sort of an incremental way to start addressing the AI risk in a large and complex organization.
So I'm hearing like policy, aligning with the standards, right? And then and documentation are basically essentially kind of key components to starting that journey. Right? And I'm curious to
Yeah, that wholeheartedly. I think the model development lifecycle specifically is a key piece of it. In life sciences, it's a highly regulated industry. We're used to building software with software development life cycles. You're used to being audit ready. You're used to being, having regulators show up on a Tuesday morning and saying, "Hey, we're here to do an audit," and you have to produce everything right then and there that says, "Yes, we've built these systems. We tested them. We have confidence that they're going to do what they say they're going to do." So in large organizations where you have some of that, you can it's extensible to AI. You can use those patterns, apply them to AI, and generally you've got a good foundation to start from. It's where we've seen the real kind of transformation and different ways of working is in more the tech startup space, where you don't have that kind of structure, right? You're building things on the fly and you're putting them out into production very, very quickly. And sometimes the rigor around documentation testing isn't always there. And what really gets you into trouble is, software development is a deterministic process. You're going to write your software, you're going to have test cases, you're going to take this action, you expect this outcome. AI is stochastic. You're going to have variability in your responses. And so you have to be able to account for that in your testing. And that's really where the tools becomes really, really important. Like to be able to have technology, and, this is what we work with Robust Intelligence, having the technology in place to be able to do automated regression testing, do more robust testing. That's why I chose the name, right? But to be able to do more robust testing of your stochastic models that you're putting into production and really reduce the risk that the model you put out there is going to do something you don't intend for it to do.
Yeah, thank you, Ed. I appreciate that. And I think for the biggest part, right, is like with this non-deterministic component, right, that is involved with with AI, right, like and that sort of like makes the difficulty in testing. So just anecdotally, I think we were just talking just before this, something that we've seen from across the board from customers when it comes to testing is we started seeing how fine-tuning models breaks internal alignment. So what we started seeing is a lot of customers who were fine-tuning. In most cases, it was like open source models like Llama 2 and what have you. And these models were working fine, right? And they had kind of their internal guardrails so that you not to sort of like say or do bad things. However, when they were fine-tuned for a specific application, all of a sudden, the guardrails are broken and all bets are off, right? And obviously, kind of like the problem that becomes, as a, for the AI organization, you're starting to look at this and say, well, if every time that we're going to fine-tune the model, there's sort of like all these unexpected pockets of vulnerabilities that are being discovered, right? And so how do I address this? So I think, I can say that knowing both of you, you have been very forward thinking about this, and you've been thinking about this for years. So how have you been thinking about this whole, aspect of testing and validation and kind of this whole shift left, organizationally?
Yeah. So, I think the fine tuning of language models, like you said, at times can break some of the controls that are in place. And that's why, what we're seeing and what we've done a lot of is using RAG-based approaches, having a vector store with the relevant documents in there that you want to provide additional context and higher performance levels in your end product. And that's worked for us really well. The shift left, the other benefit is it's cheaper. It tends to be cheaper to build, and cheaper to maintain. And then when the next language model comes out, the lift to do the upgrade is a lot less. So that pattern seems to be working. We're seeing it a lot with clients. So it seems to be the maturing pattern that we're seeing. In terms of the shift left, I think we're trying to incorporate quality earlier in the process, whether it's generative AI or traditional AI, I suppose you call it. But when you're building a model, the person closest to the quality of the model, understanding the data, is the data scientist who's building the model, or the team of data scientists that are building the model. And so teaching your data scientists about testing principles, about quality principles around fairness, equity, sort of the whole wheel of trustworthy AI, making sure that they are going into it with quality in mind, and having the testing and the tooling in place. I'm going to go back to technology again, but we found is really powerful is having steps that the data scientists go through as they're designing, building, testing their models, and then having evidence get generated that, oh, we did profile the data. We assured that the data was balanced and representative of the population we're trying to make a classification or prediction about. And having that included in each step. And then when you get to integration testing, unit testing, integration testing, system testing, that it's incorporated all the way through.
Absolutely. So I agree with everything Ed said. I'm just going to put a risk management lens on it, from a shift left perspective. So from a risk management perspective, I think, of course, validating the model, extremely important. But it's also validating it throughout the life cycle, right? So, for example, very rarely people build, models from scratch these days. You probably start with something open source. You bring it to the firm, you fine tune it, you work on it, you develop it further. That it goes into your development pipeline, and ultimately you package it up and deploy it as an application, right? So from my perspective, we need to think about the whole supply chain, right? So you need to validate at the time of procurement, right? So you need to be able to scan the artifact that you are bringing into the firm, and you need to scan it not just for your traditional malware and, for your traditional software vulnerabilities. You need to make sure you understand what adversarial machine learning vulnerabilities, exist within that model. And as you, bring that model in, you fine tune it, you build it, you need to, again, very similar to the software lifecycle, you need to scan it and validate it, pre-deployment. And then, once it's in production, you need to again periodically, test it. So again, there's a parallel here, with the software development lifecycle. I think, you need to build something very similar for the model development lifecycle as well. And I would just say, if you're in the process of doing that, or if you haven't done that, there are a few things, to keep in mind, which in my, experience are a bit of a challenge. Like vulnerability management around, AI and machine learning. It is something that, you'll have to build. And again, leverage your existing vulnerability management processes and integrate that into that. And model asset management is again something that I would highlight. Make sure you can integrate the model asset management into your existing asset management practices. So those are some of the things at the high level I would say, incorporate to really shift left, from a risk management perspective.
Makes a lot of sense. So yeah, so you're kind of like talking about the model development lifecycle. You're talking about like using, kind of open source models and, supply chain risks. I'm curious, do you see from a risk management perspective, is there like a, big difference between using kind of an off the shelf model, like a, say a ChatGPT or, or a, Claude or, whatever, right? Versus using an open source model, right? Maybe Llama 2, but also maybe something that your developers are, kind of finding off of Hugging Face. Are there like, from a risk management perspective, should we be thinking about these as, very different things, or how do you think about it?
If you look at how the regulations around this are shaping up and what the responsibility model is, at the end of the day, you are responsible for, the output of the model. If you're using it, for, a business process or to make some decision. To me, it's just a shift in responsibility. You still have to make sure that if you're using a foundational model, right, you need certain guarantees from the provider of the foundational model, because, you don't know what has gone into that. Similarly, if you're building that model yourself, you can use tools to do that. At the end of the day, you really need to think about, irrespective of what the model is, you need to get to the same outcome, right? And how would you get to the same outcome? What is the shared responsibility model that allows you to get to the same outcome? I think that is how you should think about this, and I think, we still have a lot of work to do, to get to a point where we can get to that level of confidence, irrespective of what, the deployment model is.
The things too we found is that the performance levels on the latest commercial models, the one-shot learners they're so highly performant. They're just crushing what we have at open source, right? With a couple of exceptions that get close, but the number of parameters, the amount of data that's been trained, the reinforcement learning that's gone into it, the performance is just, it's a lot of us who've been working in the field for a while, we're really surprised just at how powerful they are. So depending on what your application is, if you've got something really narrowly focused, like in biomedicine or something like that, and you can take an open source model and do some fine tuning to it and get it so it's highly performant, and maybe you want to save money on some of the usage costs, those are really the niche applications for open source. Otherwise, the commercial models are just so powerful and so performant that's where you want to go. But that's why the red teaming is so important. Like, regardless of what model you are using, you got to red team it. You got to test it. You have to find the vulnerabilities, especially in the way that you're going to use it, the way you're going to apply it, and what risks you have as an enterprise.
Good. So we kind of like shifting, although we shifted left. If we sort of like talk about shifting right, when I met each one of you, you learned a little bit about robust intelligence. You knew that we're building an AI firewall, right, which is guardrails for protecting models, which at the time people didn't think about a lot. I'm curious, like, how do you now it sort of seems trivial. You have you have an application. There's no way that you're going to deploy this application without an AI firewall, right? Without guardrails, right, around that application. I'm curious, how do you think about that? What is important when deploying an application with these guardrails? Like, what are the things to watch out for?
Yeah, I think so. You need to think about protecting the model itself, right? So you are looking at, adversarial machine learning attack, right? So how do you protect the model from model evasion attacks, model extraction attacks, right? And then on the other side of it, you also need to think about, traditional, like data loss prevention concerns, your sensitive information being leaked to, the models when, they are not your models, right? Similarly, sanitization of the input, of the output from the model. So I think the AI models just has a lot of use cases, and I think it very soon is going to become a key control. That would be really be essential. For us to be able to use these models responsibly and to be able to protect our applications as well as the use of these models.
Great, and I think it's the some of it is the risk based. How much are the models externally facing? Is there a way for somebody to get through and get that data they should not be getting at? Or is there some type of critical mission like self-driving vehicles or drones or things like that where you could do harm if somebody were to spoof it with a computer vision model or something like that. So I think they're selling us where it's time.
Yassir, Ed, thank you so much for joining me here. Looking forward to continuing our conversation offline. Thanks.